When we talked about the truss in the last assignment, we first started talking about kinematics. And kinematics, if you recall, is the relationship between displacement and strain. We'll do the same for the bar as well. For the truss, the undeformed configuration was given by the joint coordinates x1, y1, x2, y2 in uppercase, if you recall. Similarly, for the bar, the undeformed configuration is simply given by the x coordinate of each point. The joints are labeled 1, 2, 3 in the truss. In the bar, the points are labeled by the x coordinate itself. The deformed configuration of the truss is given by the joint coordinates lowercase x1, y1, x2, y2, which is a vector. For the bar, the deformed configuration is given by a function little x hat of uppercase x. Little x hat of uppercase x is the coordinate of the point whose undeformed position is uppercase x. Then the load is a vector for the truss, and the load again is a function for the bar. Displacements again are a vector for the truss, and displacements for the bar are a function which we'll call u hat of x, and that's little x hat of x minus uppercase x. Strain, if you recall, is the logarithm of little l over L. By analogy, we can define strain in the bar as the logarithm of x hat of x2 minus x hat of x1 divided by x2 minus x1, which in the limit becomes the logarithm of little x hat prime of uppercase x, which we can write as the logarithm of 1 plus u hat prime of x. Just as we came up with strain approximations epsilon BO and epsilon G and Green-Lagrange for the truss, we can similarly define strain approximations for the bar like this. Finally, for the truss, we developed a linearized strain. And for the bar, that linearized strain is simply u hat prime of x. So now we can build up the first leg of the Tonti diagram. Connecting the displacement u hat and the strain epsilon, and these are connected by d by dx. We see that now a derivative operator has taken the place of the matrix B. Also, we can say that the displacement at the left end is 0, and there is that boundary condition leg.